Hi, this is Mrs. Rate, and I'm going to use this simulation to try to explain why you get a current in a coil when you move a magnet towards it. Plus, I'm going to try to explain something called Lenz's law, the direction of magnetic field. So I have a magnet here, and this simulation shows the magnetic field lines around the magnet. So you can kind of see the magnetic field. This is just a coil, and it has the galvanometer, the really sensitive ammeter attached to it. So as I move the south towards it, you'll notice that I get a positive. And you'll notice only when I moved it that I got my current. And that's because once it stops moving, there's no changing magnetic field. This has a changing magnetic field when it moves. If I move it out, it goes negative, the opposite. Well, the reason this happens is energy. As this moves in and out, this has kinetic energy. That kinetic energy is actually turning into a magnetic field temporarily in this coil. This coil gains a magnetic field. If you use the left-hand rule for coils, you would find that as the south comes towards, that you would get a south pole right here. Why a south pole? Well, think about it. If I want to store magnetic energy, it's hard to get a south to go towards a south. That means it creates energy. If I force a south in towards a south pole in the coil, I get magnetic energy. When I pull it away, I get the opposite. Current goes in the other direction, and that's because I'm creating a north pole here, because a south wants to stay with the north, and I'm pulling it away. If I flip the polarity of the magnet, now I have my north pole. When my north comes towards, you'll notice I get my negative. That's because as the north goes towards, I'm going to create a north pole here because the norths don't want to go together. And when the north comes out, I get a south pole here because the north and the south don't want to be separated. It's kind of a strange concept, but it's all about energy. I need my kinetic energy to turn into magnetic energy. That not trying to separate the like poles or force like poles together or opposite poles being forced apart. And that turns into the electrical energy that you see in the coil.